Hello friends. So in this video we'll try to bring up the timer. We have total 4 timers. So I will show you in the dataset first which are the 4 timers. We don't have 4 timers. We have only 1 timer, but we can generate four different basically four different independent control registers are given. Using that we can generate four different interrupts. Okay. So I'm talking about the system timer which is available. So here you can see you have total 432-bit timer channels, and basically these timer channels, these four different timers are basically sourced from 164-bit free running counter. Okay. So what happens, right? This uh, each channel which is given, right? So total 4 channels are given. Each channel is has a compare register also. Okay, whenever that compare value whenever that compared value is compared register is actually compared with the 32-bit of the free running counter, and whenever when those two values matches, then the system timer actually generates a signal to indicate that a match has been found. Okay, so this is what we are going to, this signal is what we are going to use for generating the timer interrupt. Okay, and whatever signal, that match signal it generates, that is again fed to the interrupt controller, and then once that it goes to interrupt controller, then it will generate the IRQ, and that IRQ will be basically using to basically update the compare register again. So what we'll do again, we'll read the current value of the register, add the offset, which you add the future offset basically, where we want to generate the interrupt again. So that's what it is, and then come out of that interrupt handler. So again, whenever that whatever offset we have added, whenever that offset will be reached by that 64-bit free running counter, again that interrupt will be generated. So this is the procedure. Okay, for that they have given that physical base address is this is that physical base address, and it is mapped to in RPI3B. This is the raw base address, and this has been mapped to 3E003 all zeros. Okay, so that's what we are going to use as a base address, and inside this timer we don't have a lot of registers. We have only some register like system control register, control and status registers, and there is a counter for lower 32-bit lower and then counter system timer counter for higher 32 bits, and they have given four different compare registers. Okay, so four different compare registers. Okay, based on which compare register you are updating, based on that that interrupt will be generated. Okay, so basically we are going to use this compare one register. Okay, that's what we are going to update, and we'll add the offset in the compare one register, and whenever that offset will be reached by the free running counter, automatically that interrupt will be generated. So in this control and status registers, they have given key which one you want to enable, whether it's a timer 0, timer 1, timer 2, or timer 3. We are going to use the timer 1 register. Okay, we'll try with timer 1 first, and then we'll see on the other timers. Okay, and this is about that 32-bit lower 32-bit counter, which is basically free running, try to match with the free running counter, and this is a higher 32-bit counter. Okay, and we have for each channel we have a compare registers. Okay, so only these set of registers are there. So now let's start coding the driver. So let me first open our existing repo, and here we have to create one file for timer, and the corresponding also we have to create one inside peripherals. We have to create timer also, timer.h for defining those macro base address and all, and other things will be to define the timer, to basically timer.c I will define. Inside that we have to basically define the IRQ. We have to define the timer initialization, then IRQ handle. I think mostly these two will be enough for generating the timer interrupt. Okay, so let's create a timer.c. Okay, so inside this basically we'll create a timer init function. Let me check whether it's already any function with this name is not there, right? We are using a ARM timer also, right? So just to see, this is not matching with any of the same as that ARM timer in it, so it's not matching. Okay, this is system timer. Right now for FreeRTOS tick interrupt we are using ARM timer. Okay, so this timer.c is fine, and inside timer.c, okay, this is read CNT flag. This is used for the ARM timer. We are not going to use, we are going to use the system timer. Okay, so for this one basically what we have to do, we have to basically first read, we'll define some variable to read the current value. Okay, so that will define as uint32. Okay, uint32, that will be given the current value. Okay, and then this will be basically reading this current val will be reading using okay. So before this, basically that current value you have to read from this system timer counter, this one. So let's define first macro also. So this address space we have to define inside our header file. Okay, so let's go there and create one timer.h, new file, timer.h. Okay, so inside this timer.h we have to basically create a map that registers whatever we just now show in the data sheet. Okay, so to do that, let's start with that structure first. Okay, so structure, then timer registers. Okay, this timer registers will basically be UN32, and we first one we have that control and status registers. Okay, and after next 32 bit is lower bit counter, right? First is control and status 32 bit, then lower counter, then higher counter, and then we will have a compare register 32 bit compare registers. Okay, so let's do that. So now next will be UN32 counter low, and after that we'll have 32 bit of counter high. Then we have compare registers for total 4 of the timers. Okay, so this is what basically is our timer registers, which is defined in the data sheet. Now to access this we have to also define the base address. Okay, so hash define, we have to define the timer reg of timer. Okay, that is basically volatile instruct timer of this reg timers, and the base we have to define the base address. So that base address already we have defined in base.h. So instead of using this header I will just use this address directly. Basically this plus we have to define it 3000. Yeah, so this base address will be 3000. Okay, so this completes our this is how we can access this timer registers. Okay, and apart from this anything else if we need, then based on that we will be adding the header. Now let's go to the timer.c. inside timer.c first we have to include this timer.h. Okay, now after this inside current value basically we have to basically read the timer registers first. So reg timer we have defined, right? So reg timer, so first we'll be reading the so we have defined as a 32-bit current value. We'll reading the current that counter, the lower 32-bit counter, and on that 32-bit counter basically I will first after reading it I will update this current value with suppose after 1 second I want to generate this 1 second also I can create it as a macro. Okay, so let's create a macro, constant macro. That constant macro will be basically not timetic, I will say it as an after how much basically interval next will be generated. Okay, so basically that one I will initialize with some 1001 seconds. So basically this one will be 1 megahertz is that clock. If 1 megahertz is that clock, then basically uh, this interval will give 1 second delay. Okay, after that one it will be generated. After this we have to basically update the compare registers, and I am going to use the timer one. Okay, current value whatever is added that I have to update it here. So this will basically initialize the timer. Okay, and next would be to so this timer we have done. Now inside timer.h we have to basically declare this, right? So I will just copy it and define it here. Okay, that's all. Anything else? So timer has been initialized. So after this we have to write handler also. Okay, so why the timer handler it is showing is inside this basically whenever the interrupt comes we have to uh, basically first we have to clear that first we have to clear that interrupt. To clear that interrupt, either that interrupt clear we can do in the whenever it is called in the IRQ handler, and uh, okay, but before doing this we have to enable interrupt also. Okay, so let's first clear it, and then okay, this one will write it again. Schedule the next timer interrupt and then compare value we are updating. This control status we are making 0. Let's check the control status. So if your control status you are making it 0, no timer 0 match since last cleared. Okay, so this is to basically clear. This is, we are writing it to 0 and timer 1 match detected. So we don't have to write it 0. If you write it 0, then again it will not come up. Okay, so during init also we need to enable this, because otherwise that timer match will not be detected, right? So that is also where is our code? Yeah, okay. So inside a handler, what we'll try to do, we'll try to get the current value, add the interval, and then directly update the compare value registers. Clear the timer control by writing the control registers. This will directly clear it. Okay, okay. Status also shows here, right? Yeah, so this should be fine. Okay, after this we have to enable the timer interrupt controller also. So to enable that timer interrupt, we have to basically do one more thing. Just 1 minute. We have to enable that interrupt, right? So there is an interrupt controller, right? So that interrupt controller, basically we have to enable it. So here let's find out. Yeah, so here we can see, right, it is going inside that IRQ1. Okay, so basically it's there inside IRQ basic pending. So what we have to do, we can get the status by reading this IRQ basic pending, and then we have to enable it using this enable basic IRQ, and then disable it using this disable basic IRQ. So basically we have to write the basically controller also for this one. Okay, so let's try to do this also. Let's open our code, and here we have to basically add it for the time interrupt also. So interrupt thing where we can add, that's what I'm thinking. We can add in we can add one file irq.c, and there we can enable that interrupt controller. Okay, so let's add one new file inside IRQ. So irq.c. So inside irq.c, basically we'll try to enable the interrupt controller. Okay, we'll try to write a function which enables the interrupt controller. So void enable intr controller. Okay, so basically we have to enable that controller. Okay, so that controller, basically this controller is defined at this address, but it is mapped to at 0x3E00B. Okay, so corresponding to this also we have to define this register space so that we can modify this register. So let's add one irq.h, and inside irq.h basically we'll be defining all the registers. Basically to access those registers we will define that structure. Okay, irq.h. Okay, so inside irq.h now we have to basically define all this registers which we just which I have just shown to you. Okay, so let me, so this registers. Okay, so let's go to irq.h and let's start defining. So struct, then we'll have what we call as an irq regs. Okay, irq regs. Okay, we have to define here. So we have seen first one is basic pending, and then pending one. Let's try to match this. So first one is IRQ basic pending, IRQ pending 1 pending 2, then FIQ control, IRQ pending 1 pending 2, then FIQ control, then enable basic, then enable 1 2. No. First there is a enable IRQ1, then enable IRQ2, then basic. Okay, so this basic would not be here, it's there after this one. Okay, this is very important, otherwise you will be trying to enable something else. Okay, so pending basic, enable 1, enable 2, then enable basic. Again let's take about the disable IRQ1, IRQ2, then disable basic. Okay, so disable IR. Okay, so this one also you have to move it to the last. Okay, so this completes our basically definition of the IRQ regs. Okay, this is fine, and IRQ.init we have defined or not? We have not defined it, but we have defined enable interrupt controller. Instead of that we can define IRQ init. Okay, so inside IRQ.h we have defined this. Now we have to define the address registers reg IRQs of this reg IRQs, and 3F and B200. 3F B2, it's not B2, it's a B00. Okay, So this one is again wrong, B000 is there. So these are very important, okay. Volatile. Then using this IRQ reds we can directly access all these registers in the IRQ controller, okay. So now we have defined it, and so inside IRQ init, let's define the functions to initialize this, okay. So inside this, basically first we have to basically inside IRQ init, what I will try to show, right? And this is the, and our timers are coming inside IRQ basic pending, and that bit number is bit number 1, okay. So 0 to 15 is in IRQ basic, then we have 16 to 31 in IRQ pending 1, then IRQ pending 2. Let's check that. Yeah, so ARM timer IRQ pending is at 0, then mailbox IRQ pending 1 2 3. So here we have total, okay, so total 20 is there in the first IRQ pending, and after that the rest of them are there in this is there in the basic pending, then we have pending 1 and 2, so total 20 is here. So we are only concerned about this system timer, okay. So that one only that one will enable in the enable register, and in the enable register we'll enable that. But here we can see it's a ARM timer IRQ pending. Why it is showing at 0th one? Why it's a read write? It's a read function. So okay, this is just getting the status, okay, which one is pending. Okay, any other table it is shown. This is also read only. Here also we have GPU pending 1 and GPU pending 2. Okay, so one thing which I want to tell you, this timer interrupt is a part of actually that pending 1. Okay, so we have to modify the pending 1 register. Okay, this is FIQ. Anyway, we are not using FIQ. Sources are given and an interrupt enable register. Okay, so we have to use that. It's a part of GPU interrupt, right? So GPU pending 2, GPU pending 1. We are going to use the GPU pending 1, and in GPU pending 1 we have this system timer match 1. So this bit 1 we are going to use, okay. So let's go there, and basically to enable we have to do regs of IRQ. So we don't have to enable the basic, we have to enable what we have defined. Let's check there. Enable, we have to basically enable 1, okay. This enable 1 we have to do, and this enable 1 we have to set the enable timer, enable first timer, okay. That because that's what bit 0 is something else, bit 1 is system timer match 1. So bit 1 you have to basically set, so bit 1 you have clearly set it here. So this will basically enable the timer 1, okay. Now we have to include that IRQ.h inside this hash include hash include IRQ.h, and apart from this we have to IRQ handle, either we can define it here or it's already defined. We know where in FreeRTOS we have already defined in FreeRTOS stick config.c. From there just we have to basically from there, okay. Before that, let's first declare this inside our header file irq.h, okay. So this one IRQ will be initialized after this timer.h is done, and inside this timer.c we have to define the handler. Basically control status we are making it 0, and then we are adding that interval and updating the compare registers, okay. So this timer handle now should be called from that v application IRQ handler, which is available in the, let's copy this first, which is available in the FreeRTOS stick handler.c. So this is the handler which will be called whenever there any interrupt occurs. Let me show you that handler. So the v application IRQ handler, and here as you can see this is how we are managing for the FreeRTOS stick interrupt, okay. Now inside this only basically we have to check for the pending registers, and then if that pending registers is setting as 1, then we have to basically handle it, okay. So basically to let's define IRQ pending inside this handler. So you int 32 we have to define IRQ basically pending, okay. That IRQ pending 1 we have to define. From that pending 1 we have to basically read this pending 1, and inside this we have to check whether that timer 1 has come. If that has come, then basically we have to if that IRQ inside that IRQ pending one, if timer 1 has been come, then basically you have to call the timer 1 handler. Okay, so we have to paste IRQ pending. We have to check with so we have to check this with the doing not with 1 shifted by 8. We have to check with bit 1, and if that is there, then basically we have to sorry, just 1 minute. Yeah, we have to call this timer handler. Okay, peripheral timer handler, and inside peripheral timer handler, whenever it will come, it will just compare the update the compare register. Okay, so here also, to get the definition of this timer handler, we have to include uh, first let's check whether timer handler has been added in declared in the timer.h or not. Okay, let's first declare that inside timer.h. So declare the timer handler, and inside FreeRTOS config it will be called, and after that IRQ pending, this IRQ pending we are reading this, so this IRQ.h as well as timer.h, both we have to include inside this. So let's include sorry, timer.h, and then next is IRQ.h, not interrupt.h. We have to include IRQ.h. Okay, yeah, so basically handler we have added. Whenever the application IRQ handler will be called, it will check for the timer whether IRQ pending is getting generated because of this IRQ pending. If it has getting generated from here, it will basically basically it will go there, and it will check whether it has come because of the timer 1, and that timer handler it will be updating. Now we have to basically initialize we have to call these two functions, basically timer init and interrupt enable. Both of this we have to call it, and then we have to, let's call this inside main.c. So after this before creating this task, I will basically, and let's add some print in handler.c, handler of timer. Where is timer.c? Inside timer.c, and let's add some printf. Okay, so that timer in, so that we can know, okay, yeah, this timer handler has been called. Okay, to get the printf definition, we have to include printf.h. Okay, so this is also fine. Inside main, we have to enable the init IRQ, and then we have to do init timer. So both basically will be initialized. Okay, and so for getting the definition of init timer and init IRQ, we have to add the corresponding header file also. So add include timer.h and IRQ.h. Okay, so let's try to build it. Okay, so inside this he is not getting uint32. Okay, so inside this which function IRQ.h, we have to basically include let's go there. We have to basically include where it is, if it's somewhere it is defined, otherwise we'll use the standard one. Okay, reg32 is defined, but instead of that we can use that standard int function. Okay, so let's use directly this inside timer.h. we have to IRQ.h, we have to add in timer.h also, and IRQ.h also. Let's include this and do clean build, and let's build it. Now it is saying that we have some problem in timer.h. Okay, let's go there. We have not given semicolon here in timer.h. Okay, now do make and build it. So undefined reference to init IRQ. Oh, we have given some different name in IRQ.h. IRQ init we have given, not init IRQ. Okay, so let's copy this IRQ init inside main. Let's go to main function and place this IRQ init and timer. Let's check this also, whether that we have given init timer or timer init. Init timer we have given. Wait, not init timer. We have given timer init function, timer.c. Okay, it's a timer init. So we have to change it here, and also we have to change. Oh, init timer is different. Init timer is different. Okay. Init timer is for that ARM timer. Okay, that is for init timer. So we replaced it here only. So let's write comments to initialize system timer, not ARM timer. Okay, now let's build it. Timer init let's do clean and build it. Okay, so we are able to build it. So basically let's copy this to our RPI TFTP boot so that we can load inside RAM. Okay, so let's connect let's first open the picocom and let's try it. Okay, so I think these are the logs from the previous UART writes. Okay, so here now we can see the U-boot console. Inside U-boot console, now let's load the newly built kernel image. Okay, and after loading it, basically we'll see whether timer interrupt is getting generated or not. Okay, so we have successfully loaded it here. Now let's read some of the bytes. After reading, we'll basically jump to the location. Okay, now let's just close it. Okay, we'll try to find whether that timer interrupt has come once or not. So we have added some prints right inside that handler. Let's go to that timer.c. Inside that we have added timer print, timer interrupt occurred. Can you see any of this print? Timer. So here is that print semaphore. Then this one after timer interrupt rounding interrupt starts. Okay, so we are not seeing this one is getting printed anything. Directly threads are getting started, but okay. So this one timer control source, IRQ source. These are just the interrupt stats. We are not seeing the prints from here. That timer interrupt occurred. Okay, timer. Okay, so basically it has. Okay, whether that inside main.c we have added it right. We have added before this thing and IRQ init. What we are trying to let's go through our init functions and all whether we are doing correctly or not. So control C inside IRQ init what we are trying to do. Inside IRQ init we have directly enabled the bit 1. Okay, that is a rich IRQs. After enabling we are directly initializing the timer. Okay, so timer init. Let's go inside the timer init. Inside timer init we are reading that value. Okay, so what we can put some debug prints here. Let's try to print the current value what we are reading. Okay, so current timer value it will print, and that interval is anyway we are adding this value, that is fine. If this one is coming as 0, then basically the timers are not started. We have one free running counter, right? Maybe that can be the issue. So let's try to go debug one after another. So let's try to first print the current timer. We'll try to print the lower 32 bits here, and if it is giving some value, then after some time, problem is again we can read, let's read it again, so that we can say that at least it is incrementing. Okay, so just read it again and print again. Okay, we'll not update the compare register just to see whether it's a ticking or not. Okay, so this one, then again timer initialized, next interrupt at current value. Okay, only we have updated the compare value here, and after that we are just reading it and printing the current value. Okay, nothing else. Let's try to compile this and see whether this timer is running or not first. So we have built it successfully. Now let's transfer this image. So we have transferred this. Now where is our, yeah, so let's connect to picocom again. So the prints are coming from task 1, task 2. I will power off and then again power on. So yeah, now let's load that newly built image again, kernel 8.img. Here we'll try to see first whether the timer is running or not. Okay, if that is running, then our next will be maybe interrupt is not coming. Okay, so after this let's read some bytes, and after that we'll jump to that location. So let's go to 1, 2, 3, 4. Okay, so let's close this picocom so that we should not keep getting that prints. I want to just check, okay, whether whatever we have created it is coming or not. Yeah, so current timer value, it has some value, and whenever I'm reading again it has increased. So basically the timer is increasing, so there is no issue with this timer. Okay, there is no issue with this timer. Now next thing we have to check is what is happening with the interrupt. So is it that interrupt controller is not hitting, or okay, so we have to debug from that point. Okay, so timer is fine, right? From this we can clearly see that timer is fine. Other thing, any other print is coming? Task to created interrupt stats. This is all timer tick. This is fine. This is all ARM timer. Okay, so don't worry about this. This is interrupt stats. We are getting hello world from different tasks. Okay, now we have to look for the interrupt enable. Okay, so interrupt timer handler we have given. Now let's see where is our irq.c. So inside enable one, this for RPI3 it's there inside enable one only. So this is system timer. We are system timer one we are trying to use. Okay, but let's inside interrupt. We have anything else which we are not enabling? So here I think after spending some more time, I found out that there is one problem in the register itself, the register space which we have defined for the interrupt controller. Here you can see the base address is 7E00B000, but here you can see the first address starts from the 200. Okay, so this is what we'll fix it here. Okay, and after that fixing, we'll try to basically build it and see whether timer is working or not. So this is that update. And other thing, I want to remove any additions which I did in the FreeRTOS stick handler, that I will delete it. Yeah, so with this I will try to so the main change which we did is inside irq.h we just changed in that base address was wrong. Okay, so let's try to build it again. irq pending one. Okay, inside FreeRTOS stick config.c, what it is saying, irq pending one, we are trying to modify. So irq pending one. Okay, so this one we don't need to comment out. Okay, we clean then build again. Now let's transfer this to our TFTP boot. Yeah, we have transferred now we have to basically open the picocom, and I will connect the power supply to our pipe. Why you are not getting anything? Let me connect again. Okay, we are not getting. Let's see one more time. Yeah, so we got the boot console now. Now copy using TFTP boot, TFTP 0x81234 kernel 8.img. Once it is transferred, let's read some of the bytes, and after that we'll jump. Yeah, so here we can see timer one received is coming, right? So task anyway I have stopped the task, only timer one is coming. Okay, so timer one keeps on coming. So the print which we have done inside this FreeRTOS no sorry v application IRQ handler, this print is coming, and other print which is coming is from that timer.c interrupt handler. So timer.c interrupt handler, we can see the print timer one received. So as you can see here, yeah, so now we are able to see that timer one is getting generated. So now let's close this video here, and using this timer we'll try to do some more experiment, and that also I will share with you. Okay, so basically timer interrupt is up now. Okay, yeah, thank you.